That's why I did what you said. It was.
Did you fill them all out?
His team always, like, whenever he is his team.
Yeah, she never really answered like.
I was like, you know what? I'm
He can drop 100 points.
Okay, here we go. A particle moves along the x-axis. The function x of t gives the particle position at any time past 0. What's the particle's acceleration at t equals 1? Now, Khan Academy test is Wednesday, so you've got to, like, not every one of these problems is on there. This is just a general overview. But this one, you know, look for it. If its position is this, how do we find acceleration? First derivative is a velocity function. So it's 4t minus 3. So the acceleration function is 4. So your acceleration is 4, no matter where you're at. It's 4. The radius of a cone is increasing at 3 centimeters per second, and the height is decreasing at 4 centimeters per second. At a certain instant, the radius is 8 and the height is 10. What's the rate of change of the volume? If you have a first derivative, that's the changing part. Okay? That is negative 4. The radius is changing, so that's a positive 3. The volume, not given. There we go. Differentiable function is 1 over y equals 8 minus x. Find dx dt. So we have to take the first derivative of the left side. So it's y to the negative 1 equals 8 minus x. What's the first derivative of this? Equals first derivative over here. So it's negative 1. Oh, you forgot your dy dt. And dx dt. So it's negative 1 over y squared dy dt equals negative dx dt. We want to find dx dt. So we multiply both sides by negative 1, so that becomes positive. Okay? 1 over y squared is 1 over 0.2 squared times negative 0.5. So 1 over 0.04 divided by, or times negative 0.5. So take negative 0.5 divided by 0.04, and you get negative 12.5. We good with that? The radius of a sphere is decreasing at a rate of 1 meter per hour. At a certain instant, the radius is 4 meters. No, they're up there. Yep. Volume of the sphere is 4/3 pi r cubed. So dv dt equals what?
4 pi r to the second dr dt.
There you go. So dv dt equals 4 pi 4 squared 1 negative 1 because it's decreasing. So, and like Nate said right at the start of the problem, it was a.
Yes, sir. But anyway, back to it. You take the 3 times. You're taking the first derivative of that.
First derivative. Come on, man.
Get out. So the first derivative of 4/3 is 4.
What is this thing, Nate Ricky?
Oh.
Not the chain rule, the power rule.
You got it.
All right. So that would be the power rule, not chain rule.
Oh, I actually knew the answer already.
All right. Max wrote an algorithm that searches for a specific term within a large set of terms. The function is given as this. What's the instantaneous rate of change of the search length for a set of 10 terms? How do we do that? Well, yeah. Go ahead and graph. Take the first derivative. Either way. Ooh, somebody's just saying, just graph it, just graph it. Okay, so we'll graph it. Settle down. All right, so I guess if we're going to graph it, ln of 0.9x. So if we graph it, zoom 6, just get the basic graph, I guess. And let's make the window just a little bit bigger. Let's make it like 12 for x because it's searching for 10 terms. Yeah. So there it is. Okay, so then we go second trace, and then what? dy dx. And where is it at? Instantaneous rate of change at 10, so we can put in a 10, and we get 0.16. Okay, now it's talking about terms. Steps per term or steps per second. Search the number of steps. Instantaneous rate of change would be the steps per second. I would say it would be B.
Oh, look.
I said B. Why would B?
It's not B. I said B.
This is talking about the steps.
Over the. Oh. It never says seconds about it. Instantaneous rate of change of set of 10 steps in a large set of terms. Yeah, 16. Yeah, I would go with A then. Yeah. Steps per term. All right, 39-meter ladder sliding down a vertical wall. So the distance between the wall and the bottom of the ladder is increasing at 10 meters per minute. A 39-meter ladder? Do you know how long of a freaking ladder that is? 39 meters. Basically 40 yards, 120-foot ladder. Imagine being on that ladder and start sliding away from the wall. That would be, it would be scary even to be on the ladder like 10 steps up. But, oh, wow. Okay, so back to the problem. This is 39, it doesn't change. It's going this way at 10 meters per minute. Okay? At a certain instance, it's 36 meters away from the wall. So, Pythagorean theorem, what's 39 squared minus 36 squared? Really? That's why I said really?
Probably 37 squared. But it's not.
I don't think so, Nate Ricky.
It's 34.
No, how about it's 15? All right, so that's 15. We want to find how fast it's going down here. So this is a Pythagorean theorem. C squared equals A squared plus B squared. What's the first derivative with respect to time, Breezy?
BC over DT.
Okay, let him try to get the right side now, guys. dA dt
Dog drag.
plus
2b. dB dt.
all right. So the length of the ladder, does it change? No. So dc dt is what, Aspen?
0. 0.
0. You are correct. So 2 times 39 times 0 equals 2 times A is 36. This is, I would say, negative 10 because it's laying away from the wall, plus 2 times 15 dB dt.
Yeah, I think it's a positive, isn't it?
I don't know. We'll figure it out. It's positive.
All the answers are negative.
Oh. The 15's decreases, isn't it? Yeah, 15 decreases. Negative sign switch.
So let's make it positive then. If you're going to throw a hissy fit about it.
It would be negative because it's the one going down.
No, 15 is the length. It's not negative. The going down is what the answer is. So 720 plus 30 dB dt equals 0. So if we move the 720 equals 30 dB dt, negative 720, and divide by 30. 72 divided by 3. 24? Negative 24 is the answer. So it's going at 24 meters per minute down. All right, this bad boy. Okay. If we put a 3 in here right away, we get a 0 on the bottom, don't we? So we can't just put a 3 in here right away. So what should we do? First derivative. So first derivative of the top, negative 2x. First derivative of the bottom, negative sine of pi over 2 times x. Is that it? No, because you have to do the chain rule. All right. So now if we do that and we put in a 3, what's the sine of 3 pi over 2? Negative 1. Times a negative is a positive 1 times pi over 2. What is it on top? Negative 6. So it's negative 6 over pi over 2, which if you multiply by the reciprocal is, as Breezy said, negative 12 over pi. He's seen these questions a lot.
What does that supposed to mean? I had that one about 5 times.
All right. Local linearity. Okay. What is your slope? What is your slope? Negative 4. So that's this part. What's h of negative 4? Well, you got to stick negative 4 in there for x. So y equals negative 4 times negative 4, which is 16, minus 1, which is 15. What's 15 minus 4? 11. Shinedu was given this problem. A person stands at a distance 18 meters away from the intersection, watches a car driving away from the intersection, north at 3 meters per second. So it's going 3 meters per second this way. Okay. At an instant, the angle between the sight line and the intersection is 0.7 radians. Okay. What is the rate of change of the angle? So, the angle between the car and the sight line is 0.7 at a certain instant. So tangent is what we're talking about because it's opposite over adjacent, correct? Oh, they already have. Easy peasy lemon squeezy. Because it's a multiple choice. So if it was just distances, it would be this. But because we're talking about an angle, it's going to be sine, cosine, or tangent. Okay? Are you good with that? Due to the tide, the water level rises and falls in Buzzards Bay. D is the depth of water, and T is hours after midnight. What's the best interpretation of this? The value of the derivative of D at T equals 8 is equal to negative 0.5. So this is the depth of the water that's changing. So the depth of the water is changing at negative 0.5 meters per hour. Okay? At 8 a.m., the water level decreased at a rate of 0.5 meters per hour. The area of a circle is increasing at a rate of 8 pi square meters per hour. At a certain instant, the area is 36 pi. We're looking for the circumference. Okay? Well, the area of a circle is pi r squared. So, if you take the first derivative of the area, what do you get? dA dt equals 2 pi r dr dt. Okay? So, we want to, so the area is at a certain point. Oh, I screwed this one up, didn't I? No, not totally screwed it up. But I have to put in the 36 pi for the area equals pi r squared. Cancel the pi's. R squared equals 36, so r equals 6. So that's the radius I'm talking about at a certain time. The area is decreasing at 8 pi square meters per hour. So negative 8 pi is the area that's decreasing at 2 pi 6 dr dt. So if we do the math, pi's cancel, divide by 12, negative 8 twelfths is dr dt. 2 times 6 is 12, divide. So it's negative 2/3. But that's not the answer because we're looking for the rate of change of the circumference of the circle. Circumference equals 2 pi r. So dc dt equals 2 pi dr dt. So you stick the 2/3 in here. 2/3 of 2 pi is negative 4/3 is 4/3 pi. Oh, it's increasing, not decreasing. That's where it was wrong. So it's 4 pi over 3. We good? Why not, Nate? Okay, because we're given area. Well, there's so many steps because this is the one problem where it's like surface area of a sphere and volume of a sphere. Same type of thing. But this is area of a circle, circumference of a circle. So you're doing two different things, two different problems. Actually, you basically do 3 problems. Figure out your radius using area. Figure out how much dr dt is changing. And then do the circumference to figure out how much the circumference is changing at that time. The side of the base of a square prism is decreasing at a rate of 7. So a square prism has a square as a base, but it's not just essentially a cube. Wow, that's a horrid picture. Let's try that again, Mr. Bierschbach. That is slightly better. I don't know. So this is 4, this is 4, this is 9. Okay? The side is decreasing at a rate of 7, and the height is increasing at a rate of 10. Okay, find the rate of change in surface area. Surface area of a prism. Surface area equals the perimeter of the base. Wait, surface area of a prism. I can't see it from here. 2 times the area of the base, so the side squared is the area of the base, plus 2 times the perimeter of the base, which is 4 times S times H. 4 times the length of the side times the height. Is it surface area formula 2 big B plus 2 PH, right? Or it's just PH, not 2?
Yeah.
Well, now we got it right. So if we take the first derivative of the surface area, it would be 4S plus 4S times dH dt plus 4H times ds dt. Are you good with that?
Why isn't it ds, 4s, ds, dt?
Say your question one more time.
Why isn't it equals 4s, ds, dt? When you take the derivative, does that mean ds, dt?
No, we're doing
Product rule over here.
Oh,
I see what you're saying though.
no, on the
Oh, first one is ds dt. Yeah, exactly. So 4 times negative 7 plus 4 times 4 times 10 plus 4 times 4 times 9 times negative 7. So it's 16 times negative 7 plus 16 times 10 plus 36 times negative 7, which is negative 204. Okay, moving forward, moving backwards, or neither. This is velocity time graph.
moving forward, backwards.
When the velocity is above the x-axis, it's moving forward. Moving forward. When it's below the x-axis, moving backwards. You will have the chart on the board if you need it. Hey, guess what this one is? 0. Do you know how to do it? L'Hopital.
I just know if it looks really hard, it's probably 0 or infinity.
So, first derivative at the top. 2 times the ln of 6x times the first derivative of the ln of 6x, which is 1 over 6x times 6. And the 6's cancel, so it's 1 over x. On the bottom, 2 times the ln of 2x times 1 over 2x times 2, and the 2's cancel. What happens with our 1 over x's? They cancel. But still, we get infinity over infinity, so we got to take the derivative again. So it's 2 times 1 over 6x times 6. The 6's cancel. And 2 times 1 over 2x times 2. The 2's cancel. What happens? 1 over x's cancel. You get 2 over 2, which is 1. The 0 was on there just as a decoy. That's it. So, Wednesday's this test. So today is catch-up time, study for bio time, whatever.
So we can't do the test today?
Could you do the test today? Then what would we do on Wednesday? I can't hear. I don't. You can get help on it. Yeah. So I guess we could start it today. Doesn't hurt my feelings. The semester test is everybody spread out, nobody gets help. That's the Khan Academy test over this. Okay? Semester test is Khan Academy, but it counts as a normal test grade. Yes. How much of your grade? However many points it is out of the points, and then that's the points.